Lucky Land Casino, asking people, what's the weirdest place you've gotten lucky?
Lucky? In line at the deli, I guess?
Aha, in my dentist's office. More than once, actually.
Do I have to say?
Yes, you do.
In the car before my kids' PTA meeting.
Really?
Yes.
Excuse me, what's the weirdest place you've gotten lucky?
I never win and tell.
Well, there you have it. You can get lucky anywhere, playing at LuckyLandSlots.com. Play for free right now. Are you feeling lucky? No purchase necessary. Void where prohibited by law. 18 plus. Terms and conditions apply. See website for details.
Hello, it is Ryan, and we could all use an extra bright spot in our day, couldn't we? Just to make up for things like sitting in traffic, doing the dishes, counting your steps, you know, all the mundane stuff. That is why I'm such a big fan of Chumba Casino. Chumba Casino has all your favorite social casino-style games that you can play for free anytime, anywhere with daily bonuses. That should brighten your day a little. Actually, a lot. So sign up now at ChumbaCasino.com. That's ChumbaCasino.com.
No purchase necessary. VGW Group. Void where prohibited by law. See terms and conditions. 18 plus.
Tensors are the mathematical objects used in Einstein's general theory of relativity. And now they're in poster form. We have a lovely 24 by 36 inch poster that we made about tensors. And it's available on Facebook.com/BreakingMathPodcast. Just click on shop. The posters are matte, full color, and make a perfect addition to any office. So for $15.15 plus $4.50 shipping and handling, a total of $19.65, you can get this poster for you or someone you know. So check it out at Facebook.com/BreakingMathPodcast. When you click on store, and if you like our show and have a wall, I'm sure it's right for you. We're on Patreon at Patreon.com/BreakingMath. You can go there if you want to support the show. Even a $1 donation makes all the difference to us. If you enjoy the program, how about the opportunity to be essential to our show? And we'll send you a thank you message. With $1 or more, you gain access to episodes slightly early and without ads. We also include the outlines we use to produce the show. And of course, we really appreciate all of our fans, and we would certainly appreciate your patronage at Patreon.com/BreakingMath. For news about the show, we're on Twitter at BreakingMathPod, on Facebook at Facebook.com/BreakingMathPodcast, and we have an interactive website at BreakingMathPodcast.app. Tweet us your math and science memes. The world may depend on it. Tweet at us, interact with the host. Sophia is SciPodSophia with an F. Gabriel is TechPodGabe, and Meryl is FuturePodMeryl. Get in touch with us at breakingmathpodcast@gmail.com with questions, comments, suggestions, corrections, and anything else you might think would benefit our show. You can also send us an email at breakingmathpodcast@gmail.com.
Mathematics is a subject that has been used for great things over time. It has helped people grow food, design shelter, and is used in every part of life. It should be then no surprise that sometimes mathematics is used for evil. That is to say, there are times where mathematics is used to either implement or justify regressive things, like greed, racism, classism, and even genocide. So when has math been used for destructive purposes? What makes us misapply mathematics? And why can oversimplification lead to devastation? All of this and more on this episode of Breaking Math. Episode 67, Wrath of Math. I'm Sophia, and I'm going to be doing this episode alone today. But don't worry, we're going to be talking about some cool stuff today. We're going to be talking about when math goes wrong. So it's going to happen for a couple reasons. It could either be misapplied, that is to say valid math is used incorrectly, and that type of misuse of math is usually used to convince people of something, used for justifications, versus when math is misused, which is to say that valid math is used for harmful purposes, it's more directly used. This is what you see when you use math for things like bad accounting, which we'll talk about later, which can get a lot uglier than you might think. All right. First, it's you and me, listener, are going to be talking about Thomas Robert Malthus. He was born either the 13th or 14th of February in 1766 in Westcott, which is in Surrey, England, and he died 68 years later, on the 23rd of December, 1834, in Bath, which is in Somerset. So Malthus was a macroeconomist. What he did mostly was look at big trends in society. And what he saw, or what he thought he saw, and we'll talk about more about that later, is an exponential increase in population over time with a linear increase in food production ability. And what that means, if you think about it, is let's say you and me both have $1 on day one of the year. Let's say on day two, somebody gives me $1,000 and all they do is double your money. Well, you have $2 and I have $1,001. On day three, I have $2,001 and you have $4. So you don't have very much for the time being, but there is a time very soon, I believe is around like 7,000 and one for one side. The doubling quickly takes over. And a misapplication of exponential growth is actually a common theme in the misuse of mathematics. Basically, what it assumes is that some trend will continue forever. XKCD has a good cartoon about this, where somebody estimates that in 2 weeks, they're going to be married to over 14 people based on yesterday they were married with 0, and today they're married with 1. So it is a flaw in logic, and there is some support for this idea. There are countries where there are problems with supply. However, these correlate with bigger and different macroeconomic trends we'll talk about in a second. So this quote, I think, is really telling of Malthus's philosophy. We will suppose the means of subsistence in any country just equal to the easy support of its inhabitants. The constant effort towards population increases the number of people before the means of subsistence are increased. The food, therefore, which before supported 7 millions, must now be divided among 7 millions and a half, or 8 millions. The poor, consequently, must live much worse, and many of them be reduced to severe distress. The number of laborers also being above the proportion of the work in the market, the price of labor must tend towards a decrease, while the price of provisions would at the same time tend to rise. So you could really see this simplification in this trend. I don't think it's a surprise to many of you that Malthus, and Malthusians in general, perceive ideas of charity to the poor as being futile. And this has been used especially in Tory and Whig politics in England, and more recently with neo-Malthusianism, which is used sometimes to justify eco-fascism. So one of his critics at the time was Friedrich Engels, who was born on the 20th of November, 1820, and died in 1895 on the 5th of August. He was born in Barmen in the Kingdom of Prussia, and he died in London, England. So he was born somewhere in modern-day Austria or Germany. So Engels' argument wasn't perfect itself, but what he argued was that the more people there are, the quicker we can develop new ways to grow things. And in some ways, he was correct. I mean, farming has grown in efficiency so much since the start. I mean, factory farming, for all its bad things, is, nobody can say it isn't efficient, right? It also fails to account for the fact that humans aren't just, we're not like Volvoxes. We're not these simple life forms that just reproduce. Even they probably have evolved mechanisms like humans. For example, in times of famine and hardship, people don't have as many children for a period of time. There's all sorts of weird correlations that you could find like this, but suffice it to say, it's not good for an ecosystem if an animal takes over that ecosystem. And it's not good for that animal if that happens, because if it has no ecosystem, it has nowhere to go. So over time, these mechanisms have developed as an evolutionary reaction to this thing. And Stuart Brand in The Whole Earth Discipline talks about how it's contrast the 1963 inflection point showed that the imagined soaring J curve of human increase was instead a normal S curve. An inflection point is when something goes from increasing more and more quickly to still increasing, but increasing less quickly. So if you're on a roller coaster, it's kind of like when you start the curve, it's kind of like in the middle of the curve before you get to the top, where you're not curving upward anymore, but you're starting to curve downward, but you're still on the whole going up. Mathematically speaking, it's where the second derivative is 0. But yeah, these kind of simplifications lead to problems. I mean, it's led to problems before really the Lotka-Volterra model was known, which is a system of differential equations that model predator-prey relationships. You could think of it intuitively as a lot of predators eat a lot of prey, so they grow quickly, but then the prey, there's fewer of them, and then the foxes or whatever the predator is starve, so that goes down, and they go in cycles. And you can find these cycles in nature, but there was attempts, I believe it was in Washington or Oregon in the United States, where they decided to kill all the deer in this forest, and it caused mayhem. So it is really easy to oversimplify with mathematics because simple solutions are beautiful sometimes, but we have to apply the real world to everything. We have to test everything and realize that we're working with models and understand their limitations, but also know in depth what they teach us. All right, so now we're going to talk about accounting and when that is misused. So accounting is an application of math, right? It's addition and subtraction and sometimes multiplication when you're dealing with things like taxes, but at the end of the day, it's addition and subtraction. The accounting formula is pretty simple. It's your assets, like your building that you do work from, your company, truck, whatever, is equal to your equity plus your liabilities. So liabilities is things like unsold merchandise, and equity is money you have in the bank. So it should be no surprise that this system, because it's so simple and it's used for so many complicated things. I mean, at the end of the day, everybody who trades on the stock exchange, everybody brushes with accounting principles at one point or another. I mean, just the term credit card is an accounting term because when you charge something, your account is credited, which actually means it's decreased. And it's an accounts receivable, which is the money that you are supposed to give to the bank, or some similar column in your ledger is increased. So it's kind of interesting how sometimes this is misused. And one way that it was misused is in the 1980s in Enron. There's a fabulous book I recommend called The Smartest Guys in the Room, which details the rise and fall of Enron. And it reads like a crime book because, there's things like people putting company money in their personal offshore account to make it look like the next month is an increase over the current month by taking some of the excess profits and really shady things like that. And the way they accounted was absolutely no exception. Basically, they used a system of accounting. So Enron sold oil and energy. So they accounted for profits in a very strange way. Normally, profits are counted when you get the checks from the people and you decrease the amount of money they owe in your books and you increase, the cash that you actually have in your bank account. But Enron used a very obscure way of accounting, and they only got away with it because the SEC was at the time known for not being very litigious or very strong. It was the 1980s. And they recorded all the profit that they would get from a contract for natural gas or whatever when they did the sale, which made their profits look really big on paper, but it also meant that they had to increase the number of sales that they did every month to have growth, which is a much less stable way of showing growth. It's really a more frantic way of growing. But they used it because when you evaluate stock valuation is a whole thing. I mean, we could get into more economic and accounting principles at some point. They definitely deserve their own episode. But at the end of the day, it's good to know that accounting is used for a lot of good things. Every endeavor, every business, every whatever you have, a club needs to account for its things. And it's used as a way of knowing where your endeavor stands. Before accounting was a big thing in Europe, people would be like, okay, I have this barrel and that barrel, I guess. I would have these coins. But then when you had accounting, they're like, oh, okay, I'm losing money this month. And because it's a way of knowing where people are, that's why you had things like Hindu Arabic numerals, the kind that you and me use every day, being banned in Florence in favor of Rome numerals, because so they could be understood more easily by auditors and things like that. But accounting can be used validly for all sorts of evil too, because not just good endeavors need to account for their things. Every nasty endeavor you've ever heard of probably has a ledger somewhere. And this deserves its own episode, but I'll briefly mention that IBM designed machines that were essentially big accounting machines that took in punch cards for the Nazi Germany in use in the Holocaust. So this also brings us to a point. Math doesn't have to be complicated for it to have bad impact. Anybody can understand accounting with a couple hours of directed tutoring.
Hey folks, it's your buddy Zuzax here to tell you again about Brilliant. Brilliant is an amazing asset for continuing your education or just brushing up on basics. If you're listening to this show, I'm sure you love learning. Maybe you already use Brilliant. Well, did you know it also makes an amazing gift for the holiday season? Do you need another Christmas present for Grandma who loves a challenge and you feel guilty about getting her another Sudoku book? Do you need a Kwanzaa present for your dungeon master? Make sure he can crush you and your party with a course in applied probability. Educational gifts are the tradition. Brilliant can offer all those things. So don't worry about getting beat up this Black Friday over that new toy. Go to brilliant.org/breakingmath. The first 200 listeners get 20% off. And to everyone listening, have a happy, brilliant holiday. Have you ever wondered which presidents would fare best in a 46-person battle royale? Have you ever stayed up all night asking who would win, the Ninja Turtles or the Thundercats? Have you ever stayed up wondering if Batman is a fascist? Don't worry, there's hope. Nerd Forensics. Nerd Forensics is not a cult, nor is it an alternative to any traditional form of medicine. Nerd Forensics is a podcast designed to help you unwind and laugh. So listen to Nerd Forensics, available anywhere you get this podcast. Warning, this podcast may contain some content not suitable for all listeners. If you feel like this may be you, then consult your parents. If you consult your parents, you're probably too young for the show. Hey Breaking Math fans, first I want to thank you for listening. I have an important message for everyone. You can start your own podcast right now with Anchor. Anchor lets you create and distribute your own podcast. Just get an idea, record, and upload. It's just that easy. Anyone can do it. I'm on my way to accomplishing my dream, and you can too. Just get on your device's app store and download Anchor. It contains everything you need to make a podcast. With Anchor, you can put your podcast on all the big platforms. Apple Podcast, Spotify, Google Podcast, Amazon, and more. Reach the whole world with Anchor. Best of all, Anchor is free. You have nothing to lose with a free platform. Download the Anchor app or go to anchor.fm to get started.
The last thing that we're going to talk about on this episode, and I realize it's a short episode, is gambling. Because gambling is a really interesting thing, because if it were understood en masse by people as a completely logical thing, nobody would gamble. The house only makes money if the rules are weighted in its favor. And that's the thing, is that a lot of people look at gambling and see only that and think, why do people gamble? And there are actually secondary benefits that are used to keep people there. You could think of this as a smoke and mirrors behind the math, like alcohol, good company, and discussions and things like that. And games. A game of cards is fun. Some people like games of cards. Some people like the blinking lights in slot machines. That's why penny slots are big amongst people who didn't grow up playing either arcade games or video games very much. It's a need for that sort of impulse stimulus. And so how does the house do this? Basically, they analyze the game statistically, and this was done in the 1600s in a lot of places, because as people created gambling systems, people were like, oh, we could apply this fake math to real math and make sure that we increase our earnings by keeping people both engaged and winning less than we make. So, for example, in roulette, in any game, if you bet both sides, you're going to lose a little bit of money. That's just how it works. And that's kind of the statistical basis of all gambling. So I'm going to give an example here of blackjack. So blackjack, the goal is to get as close to 21 as you can, or on 21, without going over. And the aces in this game are worth either 1 or 11 points, And face cards, meaning the jack, the king, and the queen, are worth 10 points. And the players are allowed to put down whatever cards they're dealt at one at a time. They can either hit or stand. Hit means they take another card. Stand means they stay where they are. And if they go over 21, then they lose and the dealer gets their money, vice versa, and they win some money from the dealer. And the dealer actually has very specific rules. So in blackjack, I'm just going to quote this, and this is actually from bicyclecards.com. When the dealer has served every player, the dealer's face down card is turned up. If the total is 17 or more, it must stand. If the total is 16 or under, they must take a card. The dealer must continue to take cards until the total is 17 or more, at which point the dealer must stand. If the dealer has an ace, and counting it as 11 would bring the total to 17 or more, but not over 21, the dealer must count the ace as 11 and stand. So basically, it's an algorithm for how the dealer plays. And there's ways of getting around this, like if you count cards, and they don't shuffle the deck each time, you could, if they play a lot of like high number cards, you're going to be like, oh, they have a higher probability of playing low number cards. But I would never advise doing this at any casino, because best case scenario, you get kicked out forever. Worst case scenario, you get dead. There are casinos where they don't mess around with physical violence. And you went there, you knew what the deal was when you went in. Don't count cards. And problem gamblers, interestingly, have been shown by the Illinois Institute for Addiction Recovery to have a lack of norepinephrine, which is often a component of risk-seeking behavior, because risk-seeking gives you adrenaline, which is norepinephrine, sensation-seeking, impulsivity, also traits of narcissism. And our editorial position here at Breaking Math is that no mental illness is a bad one per se. Narcissism is viewed as a bad illness by a lot of people, but everything can be treated. To quote podcaster Marcus Parks, mental illness is not your fault, but it is your responsibility. So that was just a little diatribe. But it's interesting to note that these problems have a biological and psychological basis, which really shows how much of smoke and mirrors this thing is. It also goes to show how profitable it is. For example, the early lottery system, which had tickets designed by Benjamin Franklin, who would actually use leaves on a big roll of ink to verify identity. You'd verify your slip against the one that they had. And it was used to fund things like the Revolution and the early United States government to a very large extent. I mean, the lottery in my home state of New Mexico, which I still reside in, is used for a scholarship. And I think the message can either be, one, that gambling can be used for good things, but I think a bigger message is that we have the money to fix a lot of good problems already. We just need to apply it. That's my little diatribe. Every tool can be used for bad things, and mathematics is no exception. When you learn to wield a tool, whatever it is, learning about what it can do should always entail learning how you can harm yourself or others with what it does or makes. Humans have an uncanny ability to learn new things, and how to be careful with math, as well as science, should be one of them. I'm Sophia Baca, and I'm losing my voice. But I was just going to mention that I was going to delve into IQ and racial science, but those really do need to be their own episodes. I'm on Twitter at SciPodSophia, so that's Sophia with an F. And I'm also at Breaking Math Pod. That's the podcast's Twitter. We all post on that. And if you want a gift for someone for Christmas, why don't you get them a Tensor poster? We have that at facebook.com/Breaking Math Podcast. Check it out and get it if that's your thing or someone you love's thing.